So here we're trying to find the final angular velocity of the sun, as well as the ratio of the final kinetic energy and the initial kinetic energy. So for part A, we can use the conservation of momentum. So we can say that this is going to be I initial, the moment of inertia, times omega initial. This will equal omega, and the moment of inertia final times omega final. The ratio of the angular velocities will be equal to the ratio of the initial and final moments of inertia. This will be equal to 2/5 m initial r initial squared divided by 2/5 m final r final squared. Again, we're modeling the sun as a sphere, and this will equal 0.5 m initial times 0.01 r initial. So the mass is only half of the original mass, and then the radius is only 1% of the original radius. And then we'll have m initial r initial squared as well. And we find that omega final is going to be equal to 2 times 10 to the 4th. So 1, 2, 3, 4. And at this point, we can say that omega final is going to be equal to 20,000 omega initial, and this will equal 20,000 2 pi radians for every 30 days times 1 day for every 86,400 seconds. And we find that this is going to be equal to essentially 4.85 radians per second. And this is going to be essentially 20,000 times smaller. So the period is going to be equal to approximately 130 seconds. So that would be for part A, and then for part B, they're asking us for the ratio of the final and the initial kinetic energies. So this will be I final omega final squared over 2, and then divided by I initial omega initial squared over 2. This is going to equal 1 over 2 times 2/5 times 0.5 m initial times 0.01 r initial squared, and then times 20,000 omega initial squared. Let's rewrite this a little bit more compact. Omega initial squared. And then, of course, divided by 1/2 times 2/5 m initial r initial squared times omega initial squared. And we find that this is going to be equal to, again, 20,000. So we can say that kinetic energy final is going to be equal to 20,000 times kinetic energy initial. So this will be our final answer for the ratios of the final and initial kinetic energies. That is the end of the solution. Thank you for watching.